Okay, so to start off, we're going to let u equal the cubed root of tangent x, and then we're going to cube root u, and that is going to equal tangent of x. And then we are going to take the derivative of u cubed and then the derivative of tangent x. So we have 3u squared du equals secant squared x dx. Okay, so now we can't use u cubed, so we're going to have to square u cubed equals tangent x, and that is going to equal tangent squared x, and then when you cube u to the third, it's going to equal u to the sixth. So then we are going to say that tangent x is equal to secant squared x minus 1, and then equals u to the sixth. And then we're just going to add the 1 over, so it's secant squared x equals u to the sixth plus 1.
So we're going to try to get dx by itself, so we're going to let dx equal 3u squared du divided by secant squared x, which is u to the sixth plus 1. So now we're going to take the integral of u, which is u times dx, which is 3u squared du over u to the sixth plus 1, and which can be written as the integral of 3u cubed over u to the sixth plus 1 du.
Okay, so when we reach this integral, it's going to be very hard because it is u cubed and not u squared. Normally we would try to do partial fraction decomposition, but that is not an option here because it'll be very difficult. So instead of doing this, we are going to do another substitution. Okay, so the next substitution we are going to do, we're going to let t equal u squared, and then that means that dt will equal 2u du. And so now we're going to clean up this integral so that the u squared is visible. So it's going to be the integral of 3u squared times u over u squared cubed plus 1 du.
Solve for du, which we divide by 2u, so du equals dt over 2u, and now we're going to substitute t into the integral, so it becomes the integral of 3tu divided by t cubed plus 1 times dt over 2u. And now we can cancel out the u's.
Okay, so what we did now was take out the constant, which is 3 over 2, and now this integral is a lot easier to partial fraction decomposition than it was earlier in the problem.
So now we're going to use partial fraction decomposition, and we're going to find the factors of the bottom. So the factor of t cubed plus 1 is equal to t plus 1 times t squared minus t plus 1. So now we use partial fraction decomposition, and it's t over these two factors, and then it's equal to a over t plus 1 plus bt plus c over t squared minus t plus 1.
Okay, so now we are going to let t equal -1, and then when we plug in -1, we get what a equals. So a is equal to -1/3, and then we are going to let t equal 0, and then when we have t equals 0, we find that c equals 1/3, and then next we're going to plug t in for 1, and then when we have t equal to 1, we find that b equals 1/3.
So now we can write the integral of this. So we have 3 halves times 1/3, because we can factor out the 1/3 from everything, equals the integral of -1 over t plus 1 plus t plus 1 over t squared minus t plus 1 dt. So now we have to complete the square because there are no real roots in t squared minus t plus 1. So we take -1 and we divide it by 2 and then square it, which equals 1/4. So now we have t squared minus t plus 1/4 plus 1 minus 1/4, which then equals t minus 1/2 squared plus 3/4.
Okay, so now we're going to replace the denominator with what we found from completing the square. So now we have the integral of t plus 1 over x minus 1/2 squared plus square root of 3 over 2 squared dt. Okay, so now we're going to do another substitution. So we're going to have w equal t minus 1/2. So then when we solve this, we can see that t equals w plus 1/2. So when we add 1 to t plus 1, that means that t plus 1 equals w plus 1/2 plus 1. So we know that t plus 1 equals w plus 3/2. So then we can plug all of this back into the integral. So we have the integral of w plus 3/2, because that's what t plus 1 equaled, over w squared plus, and then we're just going to leave the square root of 3 over 2 squared, and then times dw.
So now we're going to split this integral into two integrals. So now we have the integral of w over w squared plus 3/4 dw plus 3 halves the integral 1 over w squared plus square root of 3 over 2 squared.
Okay, so then we took the integral and we got 1/2 ln, and then in parentheses, w squared plus 3/4 end parenthesis. And then plus 3/2 times 2 over square root of 3, and then both of those 2's cancel out. Then tangent of -1 times 2w over the square root of 3.
And then we substituted back into t, so we have 1/2 ln parentheses t squared minus t plus 1 and parentheses square root of 3 arctangent parentheses 2 over the square root of 3 parentheses t minus 1/2 end parentheses.
The integral of -1 over t plus 1 is negative ln of the absolute value of t plus 1, and there's a 1/2 on the outside. And then the integral of t plus 1 over t squared minus t plus 1 is written down from the previous answer. Next, we are going to distribute the 1/2 to each term and then substitute the t back into the u world. Using the u substitution, we know that t equals tangent to the 2/3 x.
After substituting everything back into x form, we plugged in the terms pi over 3 and pi over 6, and the final answer is negative 1/2 ln of tangent to the 2/3 pi over thirds plus 1 plus 1/4 ln tangent to the 4/3 pi over 3 minus tangent to the 2/3 pi over 3 plus 1 plus square root of 3 over 2 arctan of 2 times tangent to the 2/3 pi over 3 over square root of 3 minus 1. And then all of that minus negative 1/2 ln tangent to the 2/3 pi over 6 plus 1 plus 1/4 ln tangent to the 4/3 pi over 6 minus tangent to the 2/3 pi over 6 plus 1 plus square root of 3 over 2 arctangent 2 times tangent to the 2/3 pi over 6 minus 1 over square root of 3.